if you want to ignite a fire for cooking. But after fussing with it for a while, the firewood kept producing black smoke and wouldn't catch fire. In a flash of inspiration, you grabbed a piece of bamboo, removed the inner nodes to make a hollow tube, aimed one end at the base of the firewood and blew hard through the other end. Sure enough, this worked, and soon the fire started burning. However, constantly blowing air with your lung capacity was unsustainable. So is there a way to continuously blow air into the fire? Undeterred, clever, you found some wooden boards and assembled them into a rectangular box. Inside, you placed a wooden board fixed with 2 sticks and added a handle for manual pushing and pulling, creating a simple piston system. You made a small window on one end of the box, with a movable flap on the inner side to control airflow, which you called a dangta board. An air outlet at the bottom of the box was connected to the stove via a nozzle. By pushing and pulling the handle, you could blow air into the stove. However, this setup only worked in one direction, unable to form a continuous workflow. Ever resourceful, you opened another window on the opposite end of the box and divided the box into 2 separate chambers, each connected to the air outlet. At the outlet, you installed a wooden board that could slide left or right. When you push the handle to the right, the air pressure in the right chamber increases, pressing the dangta board to close the window, forcing air through the outlet, and pushing the valve to the left, allowing air to flow into the stove. Meanwhile, the pressure in the left chamber decreases, letting outside air push open the dangta board and enter the chamber. When you pull the handle to the left, the process reverses, ensuring a continuous airflow from the outlet. Congratulations, you've just invented the ancient double-chamber bellows, a brilliant early example of how our ancestors turned simple physics into everyday practicality.